So the way it works is the symbol that we have this radical symbol that we have, the number here determines what the toll is when you go past this boundary, either from this side to this side or this side to this side. For example, when there is no number here, it's basically the square root. So what it means, if I was standing over here, we would need two of me to move over here to become one, so they merge. Okay. If this was a 3, then 3 things from here, when they cross this boundary to go this way, they become 1. It also works the other way around. If you have a 3 up here, if you have one thing here, when you're moving this way, it has to clone itself 3 times. So let's do an example. Let's take the cube root of 32 a to the power of 5. Okay. So we want to take the cube root of 32a to the power of 5. Let's break this down into its core values. I guess that's what we're going to call it, right? If you remember, 32 is going to be, because it's even, you can divide it by 2. We got 2 times 16, and then 16 we can break down to 4 times 4. And 4 breaks down into 2 times 2. We're still on the board? We're still on the board. A to the power of 5 just means 5 a's multiplied together. So you can just go So what we're going to look for, we're going to look for triplets, because this is 3 here. So what we're going to do is combine 3 things. If you want, you can kill every branch up top, right? So this is gone, this is gone, this is gone, and these guys are gone. But those guys are gone, they're just down here. So we're going to leave that, our original question alone. So what we're going to do, we're going to combine triplets together, right? So we got 1, 2, 3, 3 2's here. We don't have another 2 to go with those, the 2 2's down there, so we're going to leave those alone because we can't combine them into triplets. Over here, we got 3 a's here, right? And we've got 2 a's left over. So these 2 2's come out of the symbol as a single 2. And those 3 a's come out of that symbol as a single a. Now, if there was anything up here in the front, whatever comes out of the symbol multiplies them here. So let's just add something to the front. Let's say this is 5a squared b. Let's say that's in the front. Let's make that a little thicker so it appears. So these 3 2's come out as a single 2. They multiply to 5. Let's write the answer here. 2 times 5 becomes 10. The 3 a's come out as a single a. They come out and they multiply this a. So a squared times a is going to be a cubed, because you h is just basically a to the power of 1. So you're adding the exponents, right? So this becomes a squared times a, which is a cubed. The b, no b's came out of the symbol, came out of the radical, so the b is just straight up b. And what you got left over is whatever is inside the radical. You got 2 a's multiplied together, which is 4, and 2 2's multiplied together, which is 4, and you got 2 a's multiplied together, which is a squared, and you still have the radical symbol because you still have things left inside the radical. So this will be cube root of 4a squared. Okay, I hope that makes sense. We're a little off the board, so what I'm going to do, I'm going to... Sorry, I had to move the camera. So what we're going to do is just write the answer right after the question, right? So the way it works is it becomes 2 times 5 was 10. A cubed, because we had an a squared and a came out. And you still had your b, and what you got left over is whatever is left inside the radical, right? So that's going to be the cube root of 2 times 2 is 4, a times a is a squared. Okay, so your solution to this thing was just that. It just simplifies to that. So that's why prime numbers are super important, because what we're going to do is, in every radical that we get, we're going to look at the symbol up here and find out what the total is to go from the inside out or to go from the outside in, because sometimes they'll ask you questions like, write it as a complete radical or one full radical, no mixed radicals or anything like this, okay? So it depends how they word the question, and that's going to depend on how you present the answer. So this is the simplest way we can go about this, and this is exactly what we're going to go about doing all the problems. Now I think the best way we can do this is, I'm just going to do one large problem, because when you solve one large problem, you solve multiple small problems at the same time. So if you have one big example, there's going to be all the little intricate details in there. Most of them will be in there anyway. It works generally in math or anything else you want. If you solve one big thing, then you've taken care of a whole bunch of little things, right? Life becomes easier. So what we're going to do is, we're going to lay out a radicals problem and go through it and break it down. And most likely the way I'm going to do it, because I have to make the problem, I'm going to start off showing you guys of how I went about making the problem, and hopefully that'll clear things up for you, and then we'll go ahead and break it down again. Okay? So I guess we'll do a loop. Figure out the question, solve the question. Okay?